Hello everyone. So today we are going to understand what is rate limiting. Rate limiting helps in protecting services from being overwhelmed by too many requests from a single user or a client. Services here means the application server on which the different services are being hosted. So there are five most common rate limiting algorithms: token bucket, leaky token bucket, fixed window counter, sliding window log, sliding window counter. Let's understand token bucket rate limiting algorithm with its pros and cons and understand how to implement them in code. Token bucket rate limiting algorithm. How it works. Imagine there is a bucket that holds token. Maximum bucket capacity determines the maximum number of tokens bucket can hold. Refill rate is a fixed rate at which the tokens are added to the bucket. Meaning, let's say we have defined a refill rate of 5 tokens per second. So in every second, 5 tokens would get added into our bucket. So basically, in token bucket algorithm, we mainly focus on two parameters, which is the maximum bucket capacity and the refill rate. Now let's understand how it works. Let's say a request from a user or a client, which is basically the application or the web app, comes to our server. So first, we calculate the tokens to be added based on the time elapsed. What does this mean? Let's say there was some request which came to our application server at some time t, and the next request is coming at some time t dash. Now, whatever the time was elapsed between t and t dash, so we'll get by taking the difference of both of the times, multiplying with the refill rate. So this gives us the number of tokens that could have added during this time. And then we will add the tokens up to the bucket capacity. What does this mean? So let's say we have defined the maximum bucket capacity is 10. So 10 tokens would be hold in the bucket at any point of time. Let's say by calculating the number of tokens need to be added by the above formula turns out to be some, let's say 4. And let's say we already have 10 tokens in the bucket. So now we can have 14 tokens to our bucket. We'll add 4 more tokens, which we have calculated here. But we'll make sure that we don't exceed the maximum bucket capacity. So it will make sure that it will always hold the token as much as the max capacity of the bucket which we have defined. After that, we will see that whether we have enough number of token so that whatever the request which has came from the client or the user could be fulfilled or not. So let's say if we have more than one number of token in our bucket, so we'll allow that request. Let's say we were not having any tokens in our bucket, we'll deny this request. So basically the step 2 and 3 are nothing but a refill mechanism of this algorithm. We'll understand this in the code. Now let's understand the refill mechanism. So let's say tokens that are added at the constant rate into this bucket is defined as 2 tokens per second, assuming. So let's say time t is equals to 0 second, we have 0 token. So now let time t is equals to 0.5 second, one token would have been added into a bucket. And let's say time t is equals to 1 second, one more token would have got added into a bucket. So like after 1 second, from the time t is equals to 0 to 1, we have 2 tokens which will be held into our bucket. So this is how the refilling into our bucket takes place. Similarly, let's say when we reach the mark of t is equals to 2 seconds, we'll have 2 more tokens which would have got added into a bucket. So total we'll be having 4 number of tokens. Similarly, when we will reach at time is equals to 3 seconds, we'll have 2 more tokens which would have got added into a bucket, which will turn out to be total number of tokens as 6, because we have defined the max capacity of a bucket as 10 in this example. And hence we'll be able to add as many as token until we are not going beyond the bucket capacity which we have defined. So this is how the refilling in this token bucket takes place. Now let's understand. So this is very straightforward to implement and understand. It also allows a burst of request up to the bucket's capacity, accommodating short-term spikes. Now let's understand this point by seeing the 3 different scenarios. So let's focus on the scenario 1, which is the burst of request. What does this mean? So let's say start. We had time equals to t is equals to 0 second. We have 10 tokens into our bucket. And at time is equals to t is equals to 0 second, we get 10 requests simultaneously to our application server. So now as we have 10 tokens in our bucket, all of these 10 requests would have been allowed. Now let's say 11th request at same time is coming to our application server. As we have exhaust all the tokens from our bucket, that request would got denied because a refill rate is also like 2 tokens per second. So after at time t is equals to 1 second, we'll have a token which would have got added into our bucket. So till then, we need any of the requests which is coming, except like more than 10 requests would get denied as shown in this example. Now let's understand scenario 2, which is sustained request after burst. What does this mean? So let's say in this scenario, we don't have a burst of request coming at particular time. So let's say at time t is equals to 0.5 second, as I explained the refill mechanism previously, we would have one token which would have been added into a bucket, right? So if any request is coming at this particular time stamp, that request would have got allowed and will again be left with zero number of tokens. Now let's say some another request came to our application server at time t equals to 1 second. So our token bucket again will be refilled with one token, and this request would also get allowed. Simultaneously at t is equals to 1.5 second, we'll also have one more token into our bucket and will also allow this request. Similarly, for t is equals to 2 second, we'll have one more token getting added into this bucket and this request will also get fulfilled. So this is sustained request after burst. Now let's understand third scenario, which is no request from user, allow token accumulation. What does this mean? So let's say for some particular time period, there were no requests which was coming to our application server. So what would happen in this case? So in this case, whenever a new request comes at some new timestamp, it will first check that when was the last request made. So based on the difference of that time and the refill rate, by multiplying with refill rate, we'll get the number of tokens which should have got added into a bucket. Once we have bucket refilled with those tokens, we'll allow the request to consume based on the request made by the user. So let's understand this. So let's say at time t is equals to 2 seconds, we are not left with any of the token. Correct. Here we have one request which got fulfilled. Now let's say our system was not having any request till some point of time. Let's say t is equal to 7 second. Request was made to our application server. Now between 2 to 7, so there are 5 seconds basically at which there will no request which hit our server. So we will first refill our bucket with the tokens which could have got added during this time, which means that we'll calculate the elapsed time. Elapsed time is nothing but the time between which the new request came in, subtracted by the previous request time, which when the request was made. So here it is 5 seconds, 7 minus 2, and the rate at which we have defined that we will refill our bucket. So 10 tokens would get first refilled. And let's say we have a burst coming at t is equals to 7 seconds. Burst meaning the 10 requests are simultaneously hitting us application server. All of those would be fulfilled. This is the third scenario. Now let's understand all of this into our code and see how and let's simulate it practically to understand how it actually works. So here is the token bucket rate limiter algorithm implemented in Java. So before starting this, this is not, this algorithm right now is implemented using a single thread, once considering the single threaded environment. We are not considering multi concurrency or multi-threading environment. In this particular example, we'll cover that in the subsequent upcoming videos, but this is particularly for a single threaded uh, application where we have just a single thread which is executing this process. So we have a class which is a token bucket rate limiter. As I previously also mentioned that we'll be focusing on two parameters, which is the capacity, which is the bucket's capacity, and the refill rate, which I have defined here, and the user request. What is this? So here we are trying to rate limit for user. So we will hold the information about every user. So this map is nothing but string is the user ID, and the token bucket is the information about how many requests a user can still make, or if he or she has exhausted the quota of the request which is allotted. So those all information will be held in this token bucket uh, basically for that particular user. And I have made as a concurrent hash map to make it thread safe. But as I mentioned here, that is a single threaded uh, application. So right now we'll not touch upon all those concepts. We'll see all those in subsequent videos where we will talk about the same algorithm in a multi-threaded environment. So this is nothing but the constructor which will initialize the maximum bucket capacity and the refill rate. And this is the main function which will check that whether the request coming from that particular user should be allowed or not. So how this works is, as I mentioned previously as well in the flow diagram, that first we will calculate the current time. So when this request is coming, basically this current time will hold that current time at which the request is getting made by the user. And as we are holding this map, basically, so we will check that whether this is the first request coming from the user. So let's say it's a first request, then we'll initialize that this bucket is basically holding the capacity refill rate for that particular user. So how many tokens that user is assigned or the quota it has been assigned. Let's say, so we'll put an entry in this map, and let's say it was not the first time request from that particular user. This won't be executed. So we'll go to the line number 20th where it will get the information of the token bucket for that particular user. So as mentioned in the flow diagram as well, we'll first refill the bucket. So refilling of the bucket is known as a lazy refilling, meaning we are not running any background process or any cron job to, I mean, run the or refill the number of tokens in that bucket. So this is like whenever the request is coming on the fly, we are trying to refill. So we don't have to have the overhead of constantly monitoring that job, which is a cron job, or which will um, keep on the specific intervals. We would have to schedule that job so that it keeps on refilling the bucket. So that is one thing. And there might be a scenarios where that scheduling time and the time at which the requests are coming, bursts are coming from the particular user might mismatch, and all of those requests might get denied. So that is also a scenario which would happen by going with that approach. But right now we are really lazy refilling, meaning whenever the request is coming, we'll try to refill our it. Okay, so this is refill method. I'll explain that what it does, but its main job is to refill the bucket based on the rate and the capacity which we have defined. Now, after refill is done, we'll check that whether this particular user is having sufficient number of tokens. So the token count is greater than 0. If it is, then we'll decrement the count and we'll say that the request has been allowed and will return true. Let's say it did not have tokens present in that particular moment at which the request was hit by that user. We'll say that you have exhausted the assigned quota and please try to some time, and will return false. Now let's understand this token bucket class and how the refill mechanism works. So token bucket class is nothing but a per bucket which we are holding for a particular user. Bucket is nothing but how many tokens that particular user has used, its remaining, when it refilled for the last time. That all information will be held here. So tokens are nothing but the tokens which a user is currently holding. So whenever it will be first request which is getting made by the user, we'll call the constructor initialize number of tokens equivalent to the capacity of the bucket. So let's say 10 tokens for that particular user has been assigned for the first time when it is calling or making the request to our application server. We'll set the refill rate as same as whatever we have set. And the last refill time, this is very much important. So last refill time for the first time request will be the current time. Definitely makes sense because whenever the request is coming for the first time, whatever it is, that time will be the last refill time for that particular request. So let's say subsequent request came after some time. So if you want to find the difference of the time between when the request was made previously and when the request is made as of now, so that could be made by subtracting the last refill time and the current time. So whenever the refilling is happening is at the point when the request is coming from that particular user. It could be the first time request or could be the second time request. But yes, so this is something which we will hold. So it is nothing but we are maintaining a previous pointer to the time at which it got refilled, bucket got refilled for that particular user. And the refill mechanism is very simple. So it will hold the current time. So basically, whenever the request came in, we are trying to refill the bucket, right? So we'll pass in the parameter current time here. Elapsed time is nothing but whatever the previous time which is getting pulled in our this last refill time parameter minus, current time minus the refill time will give us the elapsed time. The scenario three, if you remember, where we were calculating the number of tokens which would have got added into our bucket, and the number of tokens which could get added is multiplying the rate with this elapsed time, dividing by 1000 because this is in millisecond. So I'm going to convert it to second because our refill rate is per second. So to keep the unit consistent, I'm dividing it by 1000. Let's say if I have tokens to add into my bucket, I'll make sure that I am, as discussed previously as well, that capacity is nothing but the maximum bucket capacity. So let's say a particular user is having a quota of 10 requests only. So if it is making above the 10 requests within the specified time, it has exhausted the tokens, it would get suppressed or denied. The request would get denied. So it, right. So refilling would happen like, let's say we have capacity of 10 currently, and let's say after some time request is getting made and the tokens could have got added based on the rate which we have defined is, let's say, 4 tokens. So tokens is nothing but whatever tokens right now it has. Capacity is the maximum bucket capacity. So let's say it was holding, it is request, there was no previously made request, and like it has not made any request since the first request. So number of tokens it would be having is, let's say, minus the one which it was made for the first time. So let's say 10 is the capacity, 9 tokens it is having. And let's say after a good amount of time, we have, let's say, uh, 5 more tokens to get added. So around, let's say, 14 tokens could have got added into a bucket, but we'll make sure that we'll keep the minimum of both of this, so will not exceed the bucket's capacity, maximum capacity, which we have defined before the start of the algorithm. And refill time will get updated here because we are adding the tokens. So it is getting into the bucket is getting refilled. So we'll make sure that we hold that uh, time at which the refilling took place. So this is the basic refilling of the bucket. And yeah, so let's now deep dive into the main and see how it is working. So this is nothing but the capacity, which I've defined as 10. So the 10 tokens per user. So this is nothing but a per user is having 10 number of tokens at a burst. When if it wants to make 10 requests at a go at particular timestamp, it can. After that, it need to wait for some amount of time so that the bucket gets refilled. So here the refilling rate we have defined as uh, 2 tokens per second. So this is nothing but the initialization and all stuff. This is nothing but for the logging purpose, basically to see when I run this code in a terminal. And let's understand the different scenarios which I explained, right? So here, how I simulated it. So scenario one, which is the burst of request. So here, what I've made sure is I'm sending 10 requests at a go for this particular user, and I'm calling the allow request method, which is this method, basically this one for that particular user. So it will check whether all of this 10 requests currently, currently when we started that. So we have 10 tokens in our buckets. All of those 10 requests would have got satisfied. Whenever the 11th request came in, this would get denied. Okay, so this is our first scenario. Then I'm making some delay about. This is nothing but in milliseconds, so 1000 milliseconds. So 1 second delay I'm making it here, and then we'll jump into second scenario. So before jumping into the second scenario, we'll check that how many tokens right now that particular user is holding after satisfying this scenario, first scenario, right? So we'll see that when I'll run this in the terminal. So this is nothing but that. And then I'm trying to make 4 subsequent requests, right? So 4 of the requests would be made. And so whenever the, like at gap of 1 second, so this is nothing but a 1 second gap or request would be made. So after 1 second, a request would have got made. And as per our refill rate, which is 2 tokens per second, so there should be some tokens left before we jump into the third scenario. Sorry. So that again, I'll print it off that how many tokens I'm left out, and then I'll will see that where there was no application, there was no request to our application server. So there was some idle time and the accumulation, how it is happening. So let's say here I've made a delay of 5 seconds before the user resumes. Like the request when it made till the next request is going to make, the difference will be of 5 seconds I've made. So this explicitly I've added and it resumes, right? So here when it resumes, so I'm trying to make 12 requests here, right? So as it is resuming after 5 seconds and as our refill rate is 2 tokens per second, so technically 10 tokens should be there in the bucket. So first 10 requests should get satisfied by this for this particular user. This 11th and the 12th request, subsequent 11th and 12th request would get uh, denied that because we would have ran out of the capacity of the buckets token which we have. So that is what it should uh, implement while running it off. So now let's understand in our terminal by running it. So here the scenario one started at, let's say, uh, 20, which is nothing but 2023. So 20 is hours, this is minutes, and this is second. So first 10 request got satisfied. The 11th request got denied. Makes sense. Now, before starting the scenario two, we are checking how many tokens we have left off for that particular user. So it has zero number of tokens. Now, the second request which is getting made is like this was the first request it made at this time. The second is getting made at exactly 1 second after it. So now it is making after 1 second. So technically, our bucket should have 2 tokens, right? As you defined the rate as 2 tokens per second. So the request would be allowed. Now, after 1 second, one more request has been made. Again, that would be allowed. So now at the end of this, so basically 2023, there should be 4 tokens which would have got left off because we are adding 2 tokens every second. So we are making sure that based on the rate, we are adding. So at the start and the end, 4 are consumed because of 4 requests, and 4 should be left off. So yeah, so this is what before starting the third scenario, 4 tokens are left off. Now scenario third started. Here the ideal start time was like uh, is nothing but the 34th second. The request was made by that user. Now it resumes basically after 5 seconds, right? So when it resumes after 5 seconds and it makes 10 requests at the go, right? So now bucket is holding, I mean, 10 tokens because now we would have got doubt that we were already having 4 tokens and this would again add 10 more. So no, as I mentioned, we'll make sure that our bucket is always holding at max 10 tokens. So 10 plus 14, so when calculation would have happened, tokens to add would turn out to be 10 plus the remaining tokens, which is 4. So 10 plus 4 is 14, the capacity. So whatever is the minimum. So we'll have 10 tokens only, and hence only 10 requests are getting satisfied here. The 11th and the 12th requests are getting denied. Make sense? So this is the complete implementation. As I previously mentioned, this is a single threaded environment on which I have simulated this. We'll see the multi-threaded token bucket rate limiter in the subsequent video, where we'll discuss about the concurrency, about desynchronization, which would be required, and which all operations should be atomic at that point of time. That all will be discussed when we are discussing the multi-threaded token bucket rate limiter, right? So now let's understand the cons of this approach. Only con of this approach is like it is challenging to identify the correct value of the maximum bucket capacity and the refill rate. If these are not correctly identified, then we might lead into a situation where a user is making a request to our application server, and most of his or her requests are getting denied, because here we don't queue the request, we are completely denying or rejecting the request when we are running out of the tokens. So that is the only challenge which we face in this algorithm. So yeah, this was pretty much about how the token bucket rate limiting algorithm works. I hope you like the content. If you like the content, do like, share, and subscribe, and drop the comments. And see you soon in the next video. Till then, bye bye. Take care. Have a nice day.